That's right.
Okay, so we started on rational functions yesterday. We're going to finish that up today. So we are on example number 4. The first thing that we do in graphing rational functions, which is functions that have polynomials in a fraction on the numerator and denominator, is we go ahead and we factor everything and then see what cancels and what doesn't, and that gives us information. The first thing that I notice on the first one is that it has a negative in front, so we got to take that out. So I'm going to have a negative 1 and then x squared minus 6x plus 8. And then we can factor this further. So we're looking for numbers that...
-2 and -4.
Good, x minus 2 and x minus 4. I've got such a smart class today. All right, so on the bottom, we can just take this over here and factor it. So we're looking for numbers that multiply to make -6 that add up to 1.
2 and 3.
So x minus 2 and x plus 3. Good. So class, see what you remember. You can cancel out the x minus 2's. What information do we get when it cancels? A whole. So x minus 2 equals 0 will give us a whole. So x equals 2 is where there is a hole in the graph. So when we graph it, whatever part of the graph lines up with x equals 2, this line right here, we'll have to put in a little hole. And that's something that the graphing calculator does not show you. All right. So what other information can we get?
Vertical asymptote is -3.
Good. So our vertical asymptotes we can get from this right here. So x plus 3 equals 0 will give us one vertical asymptote. So that would be at -3. So vertical asymptote is at x equals -3. And I forgot to grab my little marker, so I'll grab one right now. I like to put the asymptotes in a different color just so that I know it's not actually part of my graph. And so x equals -3, we can make this vertical asymptote. Okay, and then we also would have a horizontal asymptote. Where do we find that at?
It's the fraction created by the leading coefficient.
Ooh, the fraction created by the leading coefficient. So this would be -1 and 1. So that means my vertical asymptotes.
Horizontal.
Oh, horizontal. I did that yesterday too.
Yeah.
Horizontal. Good thing you guys are smart. Okay, so my horizontal asymptote would be at -1 over 1. Y equals -1 over 1, which is -1. So that's another question that it asks. And so down here at -1, we'll put a horizontal asymptote there. So there's a couple of things that we get from this. So the whole and the vertical asymptote give us information about the domain. So in the domain, I'm going to write this out better today. It's all real numbers except x cannot equal 2 and x cannot equal -3. Or you could just put a comma and put -3. So that's the domain. That comes from the vertical asymptotes and the wholes, everything in the denominator basically. And that's because you can't divide by 0. And then if we're talking... Not equal, yes, it would be not equal. And that also is your points of discontinuity. So I'm just going to draw an arrow and say that this is my points of discontinuity. I have to say it to spell that big long word. And that's basically places where you have a break in the graph where it's not... Continuous graphs mean that you can draw through them without raising up your pencil. These are places where we'd have to stop and pause and go back and put things in. All right, we are going to use the graphing calculators to help us get the general shape of the graph. So I'm going to put my calculator up here, and we're going to graph just the original function. So remember to put parentheses around the top, so -x² plus 6x minus 8. Close the parentheses, that's the end of the top, divided by x² plus x minus 6, which is our denominator on the bottom. And if we go into a standard -10 by 10 window, Oh, I forgot I didn't have that set up that way. So when you don't have a negative 10 to 10 window, which my Y values are not because I was using this calculator for another class and I forgot, hit your zoom key, do number 6, and that'll give us a nicer window to look at. I forgot that I changed it for another class. So this gives us some good information, and you can see where those asymptotes would be. It just sort of leaves it blank right there and then down here. And what's helpful is to go into the table and get some actual points. So if you do second and graph, and then you can get some points. So over in this area at -6, it's about -3.3. At -4, it's at -8. And that just kind of gives you a general, oh, where is this piece of the graph actually? So getting a couple actual points in there will help you get the shape of the graph. And then this comes up and eventually gets close to that asymptote. And then -3, you see where it says error, that's where our asymptote is. We go to the other side. At -2, the graph is up at 6. At -1, it's at 2.5. At 0, it's at 1 1/3. At 1, it's at 0.75. At 2, it says error, and that's going to be our hole that we'll fill in a second. I'm going to go past that. I'm going to go to 4.0 to put my final point in. So there's a point right here at 4.0. You can kind of get the general shape of this here. Goes like this. And then we can go back to about where it is at 2 and erase just a little place at 2 and put in that hole that we talked about at the beginning. There's a hole at 2, and that's why it says error on the calculator for that point as well. And I think we did it all.
Yay.
Yay.